So excitation energy and ionization energy. That is what we have to discuss today. So as I told you yesterday, excitation energy is the energy required for an atom or for an electron to jump from inner orbit to outer orbit. The energy required for an atom to jump from inner orbit to outer orbit. And how much energy is required? How will you know that? For that, we should know at different orbits which are the energies. Which are the energies of the electron in different orbits. And one example is given here. Here, see E2 level energy is minus 3.4 and E1 level, that means ground state. This is first excited state. Ground state energy, how will you calculate? Minus 13.6 by 1 square. First excited state energy, how will you calculate? Minus 13.6 by 2 square. So like that we calculated these values. Minus 13.6 by 2 square is minus 3.4. Minus 13.6 by 1 square is minus 13.6. So that energy difference you have to find out. The ground state and first excited state energies we know. When you find the difference, that will give the energy difference between the two energy levels. And that difference is found, that means this is higher, less negative. This is more negative. So this is higher value. So minus 3.4 minus 13.6 we do. Then we get a 10.2 eV. So this is eV is the unit of energy. So electron need 10.2 electron volt of energy to jump from ground state to first excited state, inner state to outer state. So if it is from inner the ground state to second excited state, what will be the answer? So you have to find out E3. E3, how will you find? Minus 13.6 by 3 square. Like that you have to find out. Then E3 minus E1 you have to find out. Like that. So here the energy difference we got ground state to first excited state. See, when I say first excited state, we have to write E2 here. When I say ground state, it is E1. So be careful. The first excited state is E2. Ground state is E1. Understand? So here that difference we got 10.2 eV. So this much 10.2 electron volt energy is required for the electron to jump from ground state to first excited state. So what is the potential? Usually the one mark question that asks. See, 10.2 eV energy is required for the electron to jump from ground state to first excited state. Then what is the excitation potential? Question will be like 1 mark question. This is the energy. Then what is the potential? That is the question. What is the excitation potential corresponding to this? This is a charge into voltage. So 10.2 eV electron volt. So in order to find the potential, what you have to do? Divide by the charge of electron. E. Divide by E. 10.2 eV divide by E, charge of the electron. So we get the volt. So E and E get cancelled, we get volt. 10.2 volt. So electron, when it is accelerated by 10.2 volt potential, we apply potential difference of 10.2 volt, electron gain this much energy, 10.2 eV. So this is the way to find the potential. Just divide this by charge of the electron, E. So E and E get cancelled, we get the corresponding potential. Understood? So this is the excitation potential. So from any level, that means lower level, ground level, or first level to second level, or first excited state to fourth excited state, any state you can calculate this excitation potential. Understand? Next is ionization. So what is the difference between excitation and ionization? Ionization means completely removed from the atom. Electron is completely removed from the atom. So that potential is different from excitation potential. Excitation means from one level to the other level only. But here ionization potential means how much voltage we have to apply to remove the electron from an atom. Then only it will be ionized. Atom will be ionized when we remove the electron from the atom. So ionization is the phenomenon of removal of an electron from the outermost orbit of the atom. And in the case of hydrogen, we know hydrogen is having only one orbit, and its energy we know that is minus 13.6 eV. To remove this electron from the hydrogen atom, how much energy is needed? Energy of the electron minus 13.6. So to remove, how much energy we have to apply? Plus 13.6. Then what is the potential corresponding to that? Divide by E. So E and E get cancelled. We get 13.6 volt. So ionization potential for hydrogen atom is 13.6 volt. Potential, when potential is asked, it will be answer will be in volt. When energy is asked, ionization energy is asked, the answer will be in electron volt energy. Okay. So ionization energy, if it is asked, is minus 13.6. This is for hydrogen atom. Another atom, we have to find out the answer, substituting in the equation. Okay. And potential, if it is asked, it will be in volt, dividing by E. That is easy. Not moving. Formulas next. Formulas and problems. That I will discuss later. Today I like to start nucleus chapter. These are all the formulas. I'll send to you all the formulas of chapter atom. Distance of closest approach, impact parameter. This is centripetal force is provided by the electrostatic force of repulsion. Bohr's second postulate, mvr equal to nh by 2 pi. And with these two equations, we derived all the expression for velocity, radius, frequency, total energy, all the expressions we have derived, kinetic energy, potential energy, all we have derived from the same equation. And wave number also calculated, that formula, empirical formula, Rydberg constant. So all these formulas you have to study very well. Anyway, this time it is not there, but for the next exam, all portions will be there. January, one model exam will be there. Next. Okay, these are the problems. Today we can study nucleus, all the problems. Nucleus chapter we can study. This chapter, very simple chapter because most of the things you have studied, only one or two factors are there which is new to you. Nuclear force and all the other things you have studied earlier. So I like to ask questions only because you are knowing that. What is nucleus? Because atoms chapter we studied about nucleus. What is nucleus? Mainly it will be question answer session because you are knowing it. That's right. What is nucleus? Vishal, what is nucleus? Aditya, not signing. Vishal, what is nucleus? വേഗം പറ സമയങ്ങളല്ല ഉണ്ടോ വിശാൽ ഉണ്ടോ അനഘ വാട്ട് ഇസ് ന്യൂക്ലിയസ് Anaka. Where the other name partner to guide the other road to nucleus and then which that or I'll bury you live. I don't get what is nucleus.
Yes, teacher, it is the core of an atom.
Core of an atom.
Entirely positive charge.
And their positive charge is concentrated.
And almost all the mass of the atom is concentrated.
Yes. Then which are the constituents or nucleons? Nucleons.
Proton, electron, neutron.
Electron nucleus.
Proton, neutron.
Protons and neutrons മാത്രമുള്ളൂ കേട്ടോ അത് നിങ്ങൾ മനസ്സിൽ ഇങ്ങനെ ഉറപ്പിക്കണം inside the nucleus only protons and neutrons. Where is the position of electron in an atom? Arun, where is electron? Arunjit?
എന്നോടാണോ ടീച്ചർ? ടീച്ചർ ഇലക്ട്രോൺ അതിനെ ചുറ്റും ഓർബിറ്റ് ചെയ്തുകൊണ്ടിരിക്കും.
Yes, electrons are revolving around the nucleus. Okay. Then anybody know size of the atom? Abhinand, tell size of the atom. Size of the atom, Abhinand. എല്ലാരും ഉണ്ട് എന്നിട്ട് ആൻസർ സൈസ് ഓഫ് ദി ആറ്റം പറഞ്ഞ
ടീച്ചർ വാല്യൂ ആണ്.
വാല്യൂ സൈസ് ഓഫ് ദി ആറ്റം മുന്നിലൊരു സ്ക്രീൻ കാണില്ലേ അറിഞ്ഞൂടെങ്കിൽ അതിൽ മുന്നിലൊരു സ്ക്രീൻ കാണില്ലേ?
ഹൈഡ്രജൻ ആറ്റമിന്റെ സൈസ് 52.9 പൈക്കോമീറ്റേഴ്സ് അതാണ് ഉദ്ദേശിച്ചത്.
റേഡിയസ് ആണോ പറഞ്ഞ? റേഡിയസ് അല്ലേ? diameter of the atom is of the order of 10 raised to minus 10 meter ആണ് കേട്ടോ. ഓക്കെ, ഒരാറ്റത്തിന്റെ ഏകദേശം ഓൾമോസ്റ്റ് ആണ് നോക്കുന്നത്. പിന്നെ ന്യൂക്ലിയസ് സൈസ് ഫെർമിയിലാണ് 10 raised to minus 15 meter. 1 ഫെർമി. ന്യൂക്ലിയസ് വെരി വെരി സ്മോൾ ഉണ്ടാവും. ദിസ് ഈസ് 10 raised to minus 10 meter and nucleus is too small, 10 raised to minus 15 meter. Okay. Then atomic mass unit. What is AMU? What is AMU? 1 AMU in kilogram. Last year I think you studied 1 AMU. That I'll ask to Ashlyn. What is 1 AMU? Ashlyn. Atomic mass unit. ഞാൻ പറയാം. 1 AMU is 1/12 mass of C12 atom. Carbon 12 atom. 1/12 carbon is taken as the basic one. So 1/12 mass of carbon atom is taken as 1 AMU. And mass of one carbon atom is 1.992678 into 10 raised to 26 kilogram. In kilogram. Usually atom's mass is expressed in AMU. Mass of atom we know very very small. So we cannot express them in kilogram. So we usually express in AMU, 1 AMU, 2 AMU, like that we express atomic masses. But when you do problems and all, we have to express in kilogram. And only we get the answer in SI system. So you should know 1 AMU how many kilograms. So 1 AMU is 1/12 mass of carbon atom. This is carbon atom's mass. Very small, 10 raised to minus 26, you see. 10 raised to minus 26, very very small. Carbon atoms, 1 carbon atom's mass is this. And 1/12 of that will be 1 AMU. So we are dividing by 12, we are getting 1.6656 into 10 raised to minus 27. That is the 1 AMU. All should know this conversion. 1 AMU and kilogram conversion. 1.66 into 10 raised to minus 27 kilogram. This is almost equal to the proton's mass. Proton's mass, neutron's mass. Neutron mass is also same as proton's mass, almost the same mass in kilogram. Okay, that is 1 AMU. Then atomic number. What is meant by atomic number? Ghanasham, what is atomic number? Ghanasham. Ghanasham. What is atomic number?
Number of protons present inside the nucleus.
Very good, very good. Number of protons. It is also equal to what? Number of protons is also equal to what? Anisham?
Electrons revolving.
Yes. Number of electrons revolving in around the nucleus. Correct answer. So number of proton is equal to number of electrons. So what will be the charge of the atom, Garasham? Equal number of protons and equal number of electrons. So what is the charge? Charge of atom? Neutral. Correct. Neutral. And charge of atom will be neutral. Atom is electrically neutral. That's why. Okay. So atomic number means number of proton, which is also equal to number of electron. That is atomic number. Okay. Then another question, what is mass number? Neelima, what is mass number? Neelima? Mass number. Mass number? വളരെ കുറച്ച് കുട്ടികൾ ചോദിച്ച ആൻസർ പറയുള്ളൂ. വെറുതെ എങ്ങനെ ഇരിക്കും. ഗേൾസ് പ്രത്യേകിച്ച് ഒരെണ്ണം ഉണ്ടൂല. നീലിമ വേണ്ട, നന്ദനോട് ചോദിക്കാം. നന്ദന, വാട്ട് ഈസ് മാസ് നമ്പർ?
Yes, teacher.
What is mass number?
It is the sum of atomic number and number of protons and neutrons.
Yes. അതായത് ന്യൂക്ലിയസിൽ പ്രോട്ടോൺസ് ന്യൂട്രോൺസ് ആണുള്ളത്. അതിന്റെ ടോട്ടൽ നമ്പർ ആണ്. നമ്പർ ഓഫ് പ്രോട്ടോൺസ് ആൻഡ് ന്യൂട്രോൺസ്. നമ്പർ ഓഫ് പ്രോട്ടോൺസ് ആൻഡ് ന്യൂട്രോൺസ്. ദാറ്റ് ഈസ് മാസ് നമ്പർ. നമ്പർ ഓഫ് പ്രോട്ടോൺസ് ആൻഡ് നമ്പർ ഓഫ് ന്യൂട്രോൺ. മാസ് നമ്പർ. അപ്പൊ nucleus, protons and neutrons are there, and its total number is mass number. And protons number we know. Suppose A is the mass number, total number of protons and neutrons. Z is the atomic number. So what is the number of neutrons? A means total number of protons and neutrons. Z means number of protons. But A minus Z gives what? Aishwarya, A minus Z gives what?
Number of neutrons.
Yes, number of neutrons. We get number of neutrons. Correct. So mass number means total number of protons and neutrons inside the nucleus. Mass number. And then number of neutron will be A minus Z. That is what Then nuclei, about the size of the nucleus. I will ask a question, whether size of the nucleus is same for all atoms, whether it is same or different. I will ask to Sadhu Parvati, whether size of the atom is same or different. Or different, hydrogen, carbon, uranium, like that different elements are there. Is the size of the atom same? നമ്മൾ ആദ്യം പറഞ്ഞു സൈസ് ഏകദേശം ഒരു ഐഡിയ പറഞ്ഞു 10⁻⁻10 മീറ്റർ ഡയാമീറ്റർ എന്ന് പറഞ്ഞു. ഇനി നമ്മൾ പറയാ ഇപ്പൊ ഓരോ ആറ്റത്തിനനുസരിച്ച് മാറ്റം ഉണ്ടോന്ന്, അത് ഒരു ആവറേജ് ഐഡിയ, ഒരു ഏകദേശം ഒരു ഐഡിയ പറഞ്ഞാണ് കേട്ടോ. 10⁻⁻. ഓരോ ആറ്റത്തിനനുസരിച്ച് മാറുമോ? ഏത് പാർവതി ഉണ്ടോ അവിടെ? ഫാത്തിമ അറിയുക? എണ്ണം ഉണ്ട്. Saliha, voice not taken well. Ismail, will the size of the atom changes with the mass number? Ismail?
Yes, teacher.
Will the size of the atom changes with the mass number? Mass number ആണ് ന്യൂക്ലിയസിന്റെ സൈസ് ആണ്. അതായത് കൂടുതൽ എണ്ണം കൂടുന്നതോറും സൈസ് കൂടുതൽ. അപ്പൊ സൈസ് കൂട്ടോ? Will vary with which number? Size of the nucleus, like size of the atom vary with which number? Size of the nucleus.
Size.
Mass number, right? Mass number അനുസരിച്ച് മാറും. Because mass number is the total number of protons and neutrons. അതിന്റെ എണ്ണം കൂടി യുറാനിയം എന്നൊക്കെ പറയുമ്പോൾ 235 ആണ്, 238 ഒക്കെയാണ്. mass number. Uranium 238. Hydrogen 1, 2, 3 ഒക്കെ നമ്മൾ പറയുന്നത്. ഹൈഡ്രജൻ്റെ ഐസോട്ടോപ്പാണ് ഡ്യൂട്ടീരിയം, ട്രിഷ്യം അതൊക്കെ. അപ്പം അതിന് 1, 2, 3 ഒക്കെ ഉള്ളൂ. പക്ഷെ യുറാനിയം എന്ന് ആലോചിച്ച് നോക്കൂ, 235 ഉണ്ട്, 238 ഉണ്ട് ഐസോട്ടോപ്പ്. അപ്പോൾ മാസ് nuclear size will increase when the number of proton and number of neutron increases. The size of the nucleus will increase. അപ്പോൾ അതാണ് പറയുന്നത് ന്യൂക്ലിയർ സൈസ്. The volume of the nucleus is proportional to mass number. If R is the radius of the nucleus, assumed to be spherical, its volume of a sphere 4/3 pi r cube is directly proportional to mass number A. Or R is proportional to A raised to 1/3. R is equal to R0 into A raised to 1/3. This is a very important equation, relation connecting the size of the nucleus and the mass number. R means radius. R is equal to R0. R0 is a constant. Constant's value is given 1.1 into 10 raised to minus 15 meter into A raised to 1/3. A means mass number raised to 1/3. So as the mass number increases, radius increases. So there was a 1 mark question that from this question comes. A is different for different elements, therefore atomic nucleus, different elements have different sizes. Another question, density. Density is mass by volume. Is the density of nucleus same for all nuclei? What is your idea? Density of nucleus. How much dense it is? Whether it is denser than water or other things. All such things we have to calculate. Density is which formula? How will you calculate density? Mass by volume. See, everything for nucleus. This chapter heading itself is nucleus. So we are studying nuclear size, what all things are in the nucleus, and how is the size varying with the mass number, is the density varying with the mass number, all those things we have to study. Nucleus, this is chapter name itself is nucleus. So we are studying about nucleus of an atom. Atom പഠിച്ചല്ലേ nucleus. Okay. About mass by volume, let us find out density. Mass by volume. So mass by volume formula, because it's a spherical shape. Nucleus is in spherical shape. So we take the formula volume of a sphere. That formula we are taking m, total mass of the nucleus, by 4/3 pi r. So total mass of the nucleus. How will you find total mass of the nucleus? What all things are there? Which are the constituents of the nucleus? Protons and neutrons. So here we can write total number Mn, mass of nucleon. Nucleon means what? Nucleon means all the particles, protons and neutrons. Mn is the mass of nucleon. ഒരു ന്യൂക്ലിയോണിന്റെ മാസാണ്, അതായത് ഒരു പ്രോട്ടോണിന്റെ മാസ് എന്ന് പറയാം, അല്ലെങ്കിൽ ഒരു ന്യൂട്രോണിന്റെ മാസ് എന്ന് പറയാം. അതായത് 1.6 into 10⁻27 കിലോഗ്രാം ആണ്. Mn ഒരു സ്മോൾ m എന്ന് എഴുതിയത് കേട്ടോ. അപ്പൊ ഒരു പ്രോട്ടോണിന്റെ മാസ് ഇതാണെങ്കിൽ അതിലിപ്പോ 238 പ്രോട്ടോൺ ഉണ്ടെങ്കിലോ, പ്രോട്ടോൺ പ്ലസ് ന്യൂട്രോൺ 238 മാസ് നമ്പർ ഉണ്ടെങ്കിലോ, ആ മാസ് നമ്പർ കൊണ്ട് നമ്മൾ ഇൻഡ് ചെയ്യണം. ഒരു പ്രോട്ടോണിന്റെ മാസ് ഇത്. അപ്പൊ രണ്ടും കൂടി 238 എണ്ണം ഉണ്ട്. ഓരോ പ്രോട്ടോണിനും ന്യൂട്രോണിനും ഏകദേശം ഒരേ മാസാണെന്ന് ടീച്ചർ പറഞ്ഞില്ലേ. 1.6 into 10⁻27 കിലോഗ്രാം ആണ്. അപ്പൊ 238 എണ്ണം ഉണ്ട് രണ്ടും കൂടിയിട്ട്. പ്രോട്ടോണും ന്യൂട്രോണും കൂടി 238 എണ്ണം ഉണ്ടെന്ന് വിചാരിക്കും. അപ്പൊ അതിന്റെ എല്ലാത്തിന്റെയും കൂടി മാസ് എങ്ങനെയാ കണ്ടുപിടിക്കുക? 238 into mass of one proton അല്ലെങ്കിൽ mass of one neutron, because they are same mass. കേട്ടോ. അപ്പൊ അതുകൊണ്ട് ഇൻഡ് ചെയ്താൽ മതി. അതാണ് മാസ് നമ്പർ ഇൻറ്റു mass of one nucleon. Mass of one nucleon. അപ്പൊ that will give total mass of the nucleus. total mass of the nucleus, mass കിട്ടി. Then volume 4 by 3 pi r cubed, r equal to r0 a raised to 1 by 3. R equal to r0 a raised to 1 by 3 ആണ്. അപ്പോൾ r cube r0 cubed a raised to 1 by 3 whole cube എന്ന് പറയുമ്പോൾ a ആവും. a raised to 1 by 3 whole cube അത് a ആവും. We get the answer a into mn by 4 by 3 pi r0 cubed a cancel, and we get 4 by 3 come to the numerator, 3 by 4 mn means small mn means mass of one nucleon 1.66 into 10 raised to minus 27 kilogram by pi into r0 cube. R0's value you know 1.1 into 10 raised to minus 15 meter. So see, this is mass of a proton or mass of a neutron, that is constant, this value. Pi is constant, r0 is constant. See, all values are constant. 3, 4, mass of proton, pi, r0 is a constant. All values are constant. So in effect what we are seeing, density is found to be a constant. And we calculate the answer, we are getting 2.4 into 10 raised to 17 kilogram per meter. But you know, this value, very heavy thing. That means dense core, density is very high. See, water density is only 10 raised to 3. Water density is only 10 raised to 3 kilogram per meter. Water density അത്രേ ഉള്ളൂ. പക്ഷേ ന്യൂക്ലിയസിന്റെ ഡെൻസിറ്റി 10 raised to 17. How much density is? That is why we call it is a dense mass. Nucleus is a dense material, very heavy material. Density is very high, 10 raised to 17 kilogram per meter. Okay. Will the density changes from nuclei to nuclei? No, nucleus density is same. Understand? Density is independent of mass number. Okay. Next one, isotope. What is meant by isotope? That's a question. Isotope. Nasreen, what is isotope? Isotope. Nasreen. Nasreen answer illa. Bhumika. No answer. Aloida. What is isotope? Girls ila Nandana വിളിച്ചാൽ പറയും. പിന്നെ ഐശ്വര്യ പറയും. പിന്നെ ഒരെണ്ണം വിളിച്ചാൽ കേൾക്കില്ല പറയും. ഞാൻ തോറ്റു സാധനം വിളിച്ചു. ആദിത്യൻ, വാട്ട് ഇസ് ഐസോട്ടോപ്പ്? ആദിത്യൻ, ബോയ്സ് എല്ലാവരും നല്ല ആദിത്യൻ.
Atoms having same atomic number but different mass number.
Okay, very good. Same atomic number and different mass number. This example is given here. Hydrogen isotopes are കൊടുത്തത്. കണ്ട, അറ്റോമിക് നമ്പർ എല്ലാത്തിനും 1 ആണ്. 1. ഇവിടെ നമ്മൾ അറ്റോമിക് നമ്പർ എഴുതും, മുകളിൽ എഴുതുന്നത് മാസ് നമ്പർ. Here atomic number, mass number. Atomic number is same. That is the deuterium, the tritium. So 1, 2, 3. 3 I don't know tritium. 2 I don't know deuterium. Okay, this is 1. So hydrogen atom is having isotope. Okay, so H11, H12, H13 isotope. Isobar എന്ന് പറഞ്ഞാൽ എന്താണ്? Isobar means same mass number. ഇവിടെ same atomic number ആയിരുന്നു isotope. Same atomic number. അപ്പോൾ അത് ഓർത്തോട്ടോ, അറ്റോമിക് എന്ന് പറയുമ്പോൾ ഐസോട്ടോപ്പ് വരുന്നത് ആലോചിക്കാം. അപ്പോൾ ഐസോട്ടോപ്പ് സെയിം അറ്റോമിക് നമ്പർ അങ്ങനെ ആലോചിക്കാം. എന്തെങ്കിലും സൂത്രമൊക്കെ അങ്ങനെ പഠിച്ചേക്കണം. അല്ലെങ്കിൽ ഐസോട്ടോപ്പ് ഐസോബാർ ഇങ്ങോട്ട് അങ്ങനെ തെറ്റിയത്. ഐസോബാർ മീൻസ് സെയിം മാസ് നമ്പർ ആയിരിക്കും. സോ ഹിയർ some two examples are given. Isobar, same mass number but different atomic number. Then isotone. atoms whose nuclei having equal number of neutron. Neutron n isoton, same number of neutron. Same number of neutron. Examples and atomic number 70, 90, different. And 37, 39, that also different. Atomic number, mass number different. But you subtract it, 37 minus 17, 20. 39 minus 19, 20. Number of neutron is same. Mass number minus atomic number will give the number of neutrons. So when we subtract it, a minus set is done, we get the same number of neutrons. So that is known as isotons. Then isomer chemistry. Atoms whose nuclei having same atomic number and same mass number but different radioactive properties. Isomer. Atoms whose nuclei having same atomic number, same mass number, and do same but different radioactive property. Radioactive property atomic number same, mass number same, but different radioactive property. Such materials, such elements are known as isomers. അതിനെക്കുറിച്ചൊക്കെ ഒരു ഐഡിയ വേണം. ഐസോട്ടോപ്പ്, ഐസോട്ടോൺ, ഐസോമർ. Next, the time important. അതൊക്കെ ചെറിയ 1 മാർക്ക് എന്നൊക്കെ ചോദിക്കണം. Nuclear force important ആണ്. What is meant by nuclear force? So what all things are in the nucleus? Protons and neutrons are there. Then I'll ask a question. Which when all the protons are held together in the nucleus, what type of force we can expect there inside the nucleus? What type of force? All the protons are having positively charged. So what will be the force there between the protons? Abhinav, what type of force we can expect inside the nucleus? Abhinav ഉണ്ടാവില്ല. Ashlyn ഇല്ലേ? ഞാൻ ബോയ്സിൽ ചോദിക്കാനുള്ളത്. ആദർശ് ഉണ്ടോ? Bhadra, what type of force can we expect in a nucleus when all the protons are there? Nihala, അപ്പോൾ വേണ്ട, ഞാൻ വേറെ പറയാം. വിളിച്ചിട്ട് കാര്യമില്ല. 5 മിനിറ്റുള്ളൂ. About nuclear force, which we know there are neutrons and protons inside the nucleus. And neutrons are neutral, no charge for them. But protons are positively charged. So there will be electrostatic force of repulsion. But you know, but something extra is there which is holding the nucleons together. That is the binding energy. What is the cause of this binding energy, which is binding all these protons together inside the nucleus? That is what we have to study here. So we will expect a repulsive force, electrostatic repulsion. But you know, there is a force known as nuclear force, which is 100 times more than the electrostatic force of repulsion, which is acting there to bind all the protons and neutrons together inside the nucleus. It is a force of attraction. Nuclear force of attraction is holding all the nucleons together inside the nucleus. And the characteristics of the nuclear forces, we have studied it last year. It is the strongest force in nature. It is 100 times stronger. That's why all the protons are held together inside the nucleus. 100 times stronger than the electrostatic force. And 10⁻38 times stronger than the gravitational force. We know gravitational force is the weakest force in nature. And the strongest force is nuclear force. So that's why all the nucleons are held together inside the nucleus because of the strong force of attraction. And then short range, that you can see. Nuclear size itself is nuclear size 10⁻⁻15 meter Fermi. It is in Fermi. So that is effective only to that distance. Nuclear force is a short range force, unlike gravitational force. Gravitational force is a long range force because planets, Earth, Sun, etc. are far distance. It is effective gravitational force. And electrostatic force is also long range. But compared to these two, this nuclear force is a very short range force. It is effective up to 2 to 3 Fermi. Fermi means 10⁻⁻15 meter. Up to that only it is effective. Below this range, the force becomes repulsive. That we will explain in the graph. Below this 2 to 3 Fermi, this becomes repulsive. That means they will repel. And they will break. The nuclear will break. And when the distance is less than 2 Fermi. Okay, that I will explain with the graph. Charge independent. It is charge independent. Why it says charge independent? Because nucleus there is neutrons which are chargeless. Still there is a force of attraction. And nucleus we know there is protons. So there is actually there is a force of repulsion because charges of protons are positively charged. But this nuclear force is holding them together. So it is charge independent. It is between two protons, between proton and neutron, and between two neutrons. They are almost equally strong. So it is charge independent. Then next property, nuclear forces are non-central force. Gravitational force, it is a central force. We know it acts along the line joining the centers. Act along the line joining the centers. But nuclear force are non-central force. The forces between the nucleons does not act along the line joining the center. So that is another property. The variation of nuclear force with the distance between the nucleons is not known exactly, but from graph we can see we can have a study on this graph of variation of nuclear force with the distance. And see, actually it is not known, but some properties we can study from this graph. Nuclear force and distance. So what all things are there in the nucleus? Protons and neutrons.